Welcome to DevSecOps Cloud Tech channel. I am Blessing Olaleye. In today's session, we're exploring hybrid AWS scaling, a practical solution that combines real-time scaling and scheduled scaling to balance performance and cost. I will guide you through a real-world case study and explain each part with both technical details and simple analogies. So whether you are brand new to cloud or already advanced, you will walk away with a clear understanding of today's concept and technology. Before we go into today's scenario, let me just briefly introduce myself. I've built a strong foundation in IT and cloud through certifications and hands-on experience. From CompTIA, I hold A+ for IT fundamental and troubleshooting. For network, I have Network Plus for network concept, Security Plus for cybersecurity basics, Cloud Plus for cloud technologies, Project Plus for IT project management. I also earn Linux Essential to strengthen my system administration knowledge. On the AWS side, I'm certified as a cloud practitioner and a solution architect associate. I'm currently pursuing my bachelor's degree with Western Governor University as a cloud engineer, multi-cloud engineer. So that's all for now. Let's go into today's scenario. BrightLearn Inc. Here's our case study. BrightLearn Inc. is an educational tech company that runs virtual classroom and live product demos for universities and corporate clients. On the tech side, they run their platform on Amazon EC2 instance. Those instances are grouped inside an auto-scaling group. Everything sits behind an application load balancer to spread traffic evenly. In simple terms, imagine BrightLearn like a busy office. Weekdays, lots of professors and managers log in, so it's crowded. Weekend, the office is empty. That is where the scaling challenge comes in. The problem is clear for our client here. BrightLearn needs to handle heavy traffic for the weekdays without crashing, but they also need to save money on weekend when nobody logs in. In office time, too few workers relate to customer waiting, slow services. Too many workers equals wasted payrolls for people doing nothing. AWS scaling gives us the tool to solve this client's problem, so we can balance the whole thing between cost and exceptional service. We have two solutions we are looking into. We're going to apply them as an hybrid along the line. So the first solution is target tracking, CPU-based scaling. First, let's look at target tracking scaling policy. This is like a manager saying, I want my workers to stay about 50% busy. That means if the worker, which are the EC2 instance in this case, are above 50% busy, we scale up. We actually releases more EC2 instance to function. And if they are below 50%, we probably might scale down to ensure few workers are doing the job and we can save money. So if server worker gets too busy, auto scaling adds more our new EC2 instance. If servers are underutilized, auto scaling removes EC2 instance. Technically, AWS monitors average CPU utilization and keeps it around the target. This ensures BrightLearn can handle sudden weekday spikes in traffic automatically. Schedule scaling for weekend off. The second part is schedule scaling. This is like looking at the office calendar. Friday night, everyone goes home. Server scales to 0. Monday morning, the staff return back. So we need more servers or to scale back to normal. This prevents BrightLearn from paying for unused resources on the weekend. It automates, it's cost effective, and is predictable. So now combining the weekday and the weekend solution as an hybrid, the real power comes from combining both approaches. During the weekday, auto-scaling uses CPU-based policy to scale in and out with demand, and on the weekend, schedule scaling kicking to bring everything down to zero and then back on Monday. So if we understand this, on the weekdays we employ our CPU-based policy. That means functionality of the CPU. If the CPU is on usage is above 50%, we can decide to scale up to ensure that we have effective service for our clients. And if the CPU usage is below 50%, we basically scale down and ensure like few CPU does the job and save cost for our client. And then applying this alongside a weekend solution that on Friday at the end of the closing hour, basically all CPU are shut down. That is a schedule scaling. And on Monday morning at the proud, the opening moment, all of the CPU users comes up to normal. I mean the baseline of the CPU just come back to normal to start with, and that's start working alongside with the scaling with the CPU based policy during the weekdays. So this way BrightLearn gets fast and reliable service for customer, big cost savings when traffic is low, full automation, no one has to flip switches manually all the time. So how the system works together in basic analogy. Let's walk through this setup in simple and everyday term. Let's look at our application load balancer ALB as the receptionist in the company. This actually greets the visitors and direct them. That means as the online visitors gets to the company's website, application load balancer is the one that welcomes them as a receptionist, and the listener is the receptionist here. So a listing on the right port, what kind of service do they want, what kind of things do they want to do. And then target group is basically like the workers. These are like the set of EC2 standard that does same things. So servers that do the work, these are the target group. The auto scaling group is like the app HR manager, so it decides how many workers to keep at every point in time. So the scaling policy is the rule book, basically what rule we set, keep workers, when we have the 50% utilization, you know do you scale up or scale down applicable. Those are like that's the scaling policy, that's the rule book that we set in our company. On the CloudWatch is the supervisor, basically with the clock. So the CloudWatch monitors the performance and time, over EC2 instances to enable the HR manager, do their work, and also the target group do their work as applicable. The scaling is the calendar reminder for the weekend, and the weekend off and the weekday back on Monday morning. So that's the purpose of the scheduled scaling. So it's the calendar reminder on the weekend. Friday, it's basically enabled, it reminds the system to shut down the EC2 instance on the Monday morning. It enables this, remind the system to kick back on. The launch template is like a starter kit. It ensures every new server is pre-configured with the right image. That's talking about the right OS and everything in terms of application that needs to be installed. So we don't need to do a new configuration for everything. So it's already like it's a launch template that we already keep in place to ensure every time we spin up a new server based on our scaling policy, we have the same set of servers running at the background. So now we look at this like the entire schematic of our setup. The website gatekeeper, that is the application load balancer. We can see that over there. So The application load balancer, like I said earlier, is the gatekeeper. It's like a receptionist. Everyone comes through one front door, which is the application load balancer. The application load balancer checks where to send the request. That means every request, every client on the internet sent to the customer, to our client, it goes to their ALB and check to send where to send the request to. If one server is overwhelmed, it distributes traffic to other servers. It ensures no single server gets overloaded at any point in time, and so it avoids system crash. So the system listener, like I said earlier, is the ear of the receptionist. It listens for requests on a specific port, like port 80 for HTTP. Once it hears a request, it knows which target group set of servers to forward it to for the applicable jobs, And now it comes to our worker, and that is the EC2 instance that does the computation and every of the critical jobs, on our website. These are the workers that are doing the job. Each one possesses demo request. If traffic grows, auto scaling spins up more servers, more workers. If traffic shrink, auto scaling spins down to to the bare minimum required, the baseline. It's like hiring temporary staff when the office get busy. In that way, we can save costs. So we look at our auto scaling group. The auto scaling group is like the hiring manager, like I explained earlier. If workers are overwhelmed, we hire more. If workers are idle, we send some more home. This keeps the workforce balance with the workload and enables us to save costs for our clients. CloudWatch. We consider CloudWatch in the literal time as a supervisor and the clock of our online or our cloud environment. Amazon CloudWatch is both the supervisor and the clock. It checks how busy servers are, the CPU utilization or usage. It also knows the time which let it trigger schedule scaling. For example, that aspect of the CloudWatch should work with times on the weekend, the Friday, and on Monday morning. So it enables us to trigger schedule scaling on the weekend, shutdown, and weekday to restart. The target group. The target group is simply the pool of the workers. That's the pool of the EC2 instance that does the job. The application load balancer forwards traffic to this group, and if no worker failed, the auto scaling group if one worker fails, we basically just triggers and replaces it. This ensures reliability at every point in time and enable quality service for the clients to our client in this context. The launch template. So what is the launch template? The launch template is like a starter kit. We don't want to at every point we want a new C2 instance, we have to reconfigure it ourselves or do something crazy. This a lot of work and it doesn't match up with what we need in this context. So a launch instance is like a starter kit. Every time auto scaling adds a new worker, it uses the launch template to install the right operating system. If it's Linux, what kind of operating system we're employing in this context for our servers. Load the necessary application like the Apache, apply the correct configuration, everything that needs to be done, right configuration. That way every new server is consistent and they are ready to go. Scaling policy CPU. This is the rule book. If CPU goes above 50%, it's the rule book says scales out. If CPU goes below 50%, the rule book says scaling. That is the scaling policy, and based on CPU utilization. So it is the balance that keeps everything smooth and cost effective. So we also look at the scheduled action weekend off. This is the calendar reminder for Friday. Every Friday night, the system scales down to 0. No worker stays around when no customers are expected. That means we don't keep any EC2 instance hanging. We don't keep acquiring cost on AWS platform. We basically scale down to 0, and that saves BrightLearn money. Scheduled action weekday on, and this is the calendar reminder for Monday. On Monday morning, server spins back up so that BrightLearn is ready when customer return. Again, it's all automated. So we can see how all of this works together in the architectural diagram that we have here. you know so from the listener to the CloudWatch to the load balancer to CloudWatch alarm CPU, scheduled action weekend off, scheduled action weekday on, scaling policy CPU, auto scaling group, launch template target group. You can see how this whole diagram works together from the explanation. So users from users to application load balancer to listener to target group. Auto scaling group manages workers count, scaling policies keep CPU balance, CloudWatch supervises and triggers scaling, scheduled action handles weekends, launch template ensure consistency. What is the result of all of this wonderful architecture? Weekdays auto scale with demand, weekends scale to 0, save money. So this diagram shows the hybrid solution in action. Target tracking plus schedule scaling. It does guarantees readiness for traffic, cost saving during downtime, automatic operation with no manual effort. Somebody will say, why does this matter? Without hybrid scaling, too few servers, frustrated customer, too many servers, wasted money. You keep too few servers, you have crashes, you have latency issues, and a lot of issues applicable to such architecture. With hybrid scaling, our website is always fast, companies save money, everything runs on autopilot. That is the balanced way every modern business wants, and that's what we are giving to the customer in this contest. So for our references, here are the key AWS services we covered: EC2 instance, VPC, virtual private cloud, application load balancer, listener, target group, launch templates, auto scaling group, scaling policy, CloudWatch alarm, and schedule scaling. If you want a deeper insight into all of this technology, kindly reference them on AWS platform. You can go through the documentation and much more about the configuration. I do appreciate our time on this on this particular scenario. I will be looking forward to seeing us once again. So that is the story of BrightLearn Incorporation and AWS Hybrid Scaling. It's a real-world example of how cloud computing gives us both performance and cost optimization through automation. Thanks for watching DevSecOps Cloud Tech. Once again, I'm your host, Blessing Olale. Don't forget to like, share, and subscribe. I will see you in the next scenario. Have a good one.